Auto insurance can all seem the same until it comes time to use it. So don't get stuck paying more for less coverage. Switch to USAA Auto Insurance and you could start saving money in no time. Get a quote today. Restrictions apply.
USAA. Hey everybody, welcome to the Single Tracks Podcast. My name is Jeff, and today my guest is Rich Bernoulli. Mountain bike frame building is both an art and a science. To many mountain bikers, it's a bit of a mystery as to how frames come together. So today we've asked Rich, who's an expert on frame building, to shed some light on how bike frames are designed and built. Rich has been teaching frame building at the United Bicycle Institute for 9 years, and he joins us today to shed some light on the subject. Thanks for joining us, Rich.
Yeah, thanks for having me.
So tell us a little bit about your background and what exactly you do at the United Bicycle Institute.
Sure. So I've been into bikes pretty much my whole life. I've got 3 older brothers that they were all into it. And, the youngest always wants to be like the older. So got into it pretty aggressively when I was a kid. And it's always been a part of my life. I've gone through bike shops and I worked for Yeti Cycles for 2 stints. And I worked with James at Black Sheep for a lot of years in some capacity or another, and then moved here to Oregon in 2008 or 9, and I've been at UBI ever since. So, and what I do here at UBI is I teach primarily the frame building side of things. I'm the director or manager or something like that on that side of the building, and then I teach the mechanic side whenever they need help. Somebody's on vacation or something like that. So that's what I do.
Yeah, that's cool. So how did you learn to build frames? How did you first get into that yourself?
So, when I was at Yeti, I would peek over, around the curtain and watch Vega, the old Yeti welder, watch him weld for a while. And then he let me kind of step on the pedals and blew a hole in aluminum faster than you could blink. And but something happened there. I kind of got the itch. And then also in my undergrad, I was part of a steel bridge competition, and we had to fabricate a 1/12 scale model bridge. And nobody on my team wanted to fabricate it except for one other guy. So it was just me and him. And I got to learn how to weld. It was all straight, thicker tubing or a thicker plate. Mm-hmm. But that kind of solidified the idea that it's pretty cool to build stuff and melt metal. And then when I was in grad school, I was also working at Black Sheep at the time, but I took a TIG welding course at a community college and went crazy. I just went nuts. So I fulfilled the course requirements almost halfway through. And then the rest of the class, I could just bring in material and just weld away. So I just practiced and practiced and practiced and practiced. And came here and was able to show some ability and some knowledge, and definitely got humbled because there's a lot that I realized I didn't know, and I still don't. But it's fun. Yeah, I get to share the love. So
yeah, that's cool. So you mentioned TIG welding, I think, which is one of the forms of welding that's used in bike frames. Can you explain what the terms brazing and TIG welding mean, especially when we're talking about mountain bike frames?
Yeah, absolutely. So just fundamentally, welding is when you take a parent material. So let's just say, for example, steel. You have steel tubes and you melt that parent material. So you're going to take it to a temperature where it's actually melting the tubes. And then you're going to add the same or very, very similar alloy to the seam or the area that you're heating. So you're basically adding the same material to the parent material, and you're heating the parent material enough that it's melting, I guess.
Yeah, that's basically the two have fused together, I guess, right?
Yeah. And brazing is fundamentally different in 2 cases. One is you're never melting, or you shouldn't be melting the parent material to its melting point. It should still be a solid, but you are melting a dissimilar metal. In doing so, when you melt the dissimilar metal, if you're using a correct process and metal, you get what's called a metallurgical bond between the 2 metals.
Okay. So, yeah, it sounds like you can use either one of those processes when you're building a bike frame. Why would you choose one over the other? What are some of the pros and cons of each?
Yeah, there's a lot. There's a lot that goes into that. So let's say you're somebody who's just starting out. It's going to be a lot more cost effective to, or at least a cheaper start if you're doing brazing, because welders they're just a lot more expensive. And brazing is, for the most part, it's an easier process to pick up and learn. And, even fillet brazing, which we can talk about if you'd like, it's got a steeper learning curve than lug brazing. But in the end, if you know what you're doing, you get some practice, you can always file off parts of the brass or bronze that you didn't want or don't want. So it's not like welding where you've got to take a lot of time just to learn it, and you have to spend a lot of money on the machine. So that would be one consideration why you would go with one method versus another. Aside from that, you're looking at, what kind of aesthetic do you want? A lot of people like the organic look of the fillet braze, where it looks like one tube is kind of grown into another. You don't really see a seam. Some people like the lugs, that aesthetic. And then other people like, sort of the fingerprint look of a weld. So the personality of the builder could go into it. And then also, finally, maybe it could be material. If you're, set on titanium, then you're not going to be brazing titanium. You're going to be welding it. So steel is pretty forgiving in that it has a lot of processes that you can do and do well. With titanium is not so much. You're just going to weld it.
You mentioned titanium, and obviously there are a lot of different materials that can be used to create mountain bike frames. These days, carbon fiber is hot, and we're hearing about companies that are starting to build their own carbon fiber frames. Does UBI teach carbon frame building, or how does that fit into sort of the programs that are offered there?
We do not offer it. I would love the opportunity to get into that, like get into teaching it. Carbon there's a reason why it's popping up everywhere, is because it's a pretty awesome material as far as any kind of engineering application or performance application is, at least relative to the metal work that we do. We've, looked at it as far as UBI is concerned in teaching it, but there's definitely some obstacles, both with the state and having our license and then also just the material itself. So it may come down the pipe at some point. So for those of you who are interested, keep checking in.
So what are you seeing in terms of carbon fiber? Like, what's the fabrication process like? How does it compare to, more traditional metal frame construction? Yeah.
So the current methods that we're seeing is very similar to, or it can be very similar to metal construction, in that there are some frame builders that are, particularly the smaller custom builders, that are doing what's called a tube-to-tube construction. And what that means is they're taking prefabricated tubes, and they're cutting them like you would a steel tube or a titanium tube. They're mitering them to match a head tube and a seat tube or a bottom bracket. And then they bond those together, and then they'll wrap it with what's called a pre-preg layup. So pre-preg means it's a pre-impregnated sheet of carbon and resin, and you wrap that around the joint, and you put it under some compression and some heat, and it cures, and then you take it out and you basically buff it and finish it to the aesthetic that you want, and then they add paint and all that. So the other methods that we're seeing is kind of a little more expensive, but it's kind of filtering down to some of the custom builders as well, and it's called a net molding technique, where they basically think of two gigantic clamshells, and inside the clamshell is a mold of whatever shape of tube you want, and you have a particular layup schedule, they call it, and it's basically just how you lay different sheets of this carbon. You put it in there, and you can have either a bladder or some kind of disposable or removable molding component that allows you to compress the sheets together. And then that goes in under some heat as well. And then when it's cured, or when it's done, you've got a cured tube. And what some manufacturers are doing is they're taking that process in certain tubes and then using it as almost like a tube-to-tube construction. So it's kind of a combination of both. When you look at like the bigger companies, the Treks, the Santa Cruzes and Yetis and all those guys, they're using the net molding for all of the whole like front triangle could be net molded. So that's the big difference between, the smaller frame builders that you're seeing offering custom carbon versus the big guys.
Okay. So yeah, we talked about a number of these materials that people use to create mountain bike frames. What are some of the considerations that people need to make when it comes to material selection?
So it depends on what perspective. So if you're looking at it from, a frame builder's perspective, it's going to be what are they like working with? What are they comfortable working with? Are they a brazier? Are they a welder? If you're looking at it from the consumer side of it, there's a whole lot more questions like, what are you going to use it for? How long do you want it? What's the price? And then a lot of it can go into what we're seeing. I think we're seeing a lot of is kind of the mystique behind it. So as a frame builder side, if you're a welder or if you enjoy welding more, then you're going to be sticking to, either TIG welding steel or tie. I think most frame builders like the idea of both, being able to do both, but the option for doing tie is pretty popular just because it's regarded as a more favorable material. Aluminum is still in play. There's just not a whole lot of people that are custom frame builders that are offering it, but the ones that do seem to have a pretty good niche still. They're doing pretty well. I'm speaking primarily of Rock Lobster. Paul Sadoff at Rock Lobster is doing really well, and he deserves. He's an awesome frame builder and definitely knows what he's doing. But he can still handle aluminum, and he does a lot of steel frames as well.
Yeah, I was going to ask that. Why don't you see more custom frame builders using aluminum?
It's I don't know if it matches the kind of client. I think if people are saving up for a custom built frame, they're not looking at. I think people often look at aluminum as like a inferior material, and in certain cases it can be for sure. It's not going to have the lifetime that steel or certainly titanium has. So that might be an issue, but otherwise I can't answer that. I don't know if it's built by somebody who knows what they're doing. You can have an aluminum frame that will last you a long time, but it certainly has its limitations.
Yeah, that's really interesting because, back in the 90s, that was the big thing, right? It was aluminum. It was better than steel for a lot of reasons, or we were told that.
Yeah.
And obviously it can be lighter weight than steel in some ways. So there really isn't any reason not to use it in terms of, is it harder to work with or to weld on? Do you need specialized equipment for it? Or is it just preference? There isn't as much demand for custom aluminum bikes?
I think it's a little bit of all of the above. The aluminum does take a different welding setup. You have to weld what's called AC as opposed to steel and tie being DC. And if you're used to only welding steel and tie, then welding aluminum is going to be a challenge for sure. But I think anybody who's into it can weld aluminum as well. But otherwise, it does require heat treatment after weld, or at least artificial aging after it's welded. And some people don't want to get into that. It typically is painted or anodized, and some people don't like that idea. Aluminum has great corrosion resistance, except for saltwater solutions. So your sweat or living near the beach or something might be a thing to think about. But I think honestly it's just not. It doesn't fit the custom frame builder mantra, if you will.
Yeah.
Like steel is, still holds on a little bit because of the durability and the what we can do with it. But I think most of the frame builders I know, they're definitely doing a lot of work in tie.
Yeah, that's interesting. So let's talk about some of the characteristics of some specific frame materials. So we've been talking in general terms about, steel and aluminum, but even within steel and aluminum, there are different sort of variations in alloys, right?
Yeah, and I think to the average consumer, they're never going to know the difference. So if you look at aluminum, for example, there's 6,000 series and 7,000 series, and for the most part, it's what that comes down to is how they're fabricated and what needs to happen through the fabrication process. I think once it's a finished frame, I don't know if, there's people out there that are going to know the difference. And that goes for steel as well. There's a lot of companies have their proprietary alloys that they have terms for. And I think, people who are paying a lot of money for a custom built frame, they like to see those specific stickers, for Columbus or at a Chai or whatever. But I got to be honest, if you were to blindfold me and put me on two steel frames, they're the exact same thing, only one's got, one kind of steel tubing versus another, I don't think I would notice a difference.
That's good. It's good that you admit that. Yeah.
And I'll share another secret with you. If you've got a frame builder that, swears solely on using one manufacturer's tubes, that I don't look at that as, from my perspective, I don't look at that as an awesome thing to market, because one, there's some awesome tube manufacturers out there, and there's not just one. And two, I know how Columbus works, and they don't just make any tube anytime. They have runs of them, which means that you could likely, as I have, ordering tubes for UBI, come into a scenario where a tube's not available. And if a tube's not available, but you only are, telling your customer that you only use one tube, then your customer is going to have to wait even longer, which some people, they pride themselves on having a long wait list, but other people, they pride on being able to get you a bike quickly. So I think if you have a particular frame builder is like, I only use, brand A, that might be a little bit of a short-sightedness in my mind, because there's other ways, and other manufacturers make tubes that other manufacturers don't, that you might want to use to hone in the feel or the style or the type of the bike. So just my 2 cents.
Yeah, that's a good tip. I mean, as a product reviewer too, I think people expect maybe that we're able to tell a difference between that stuff. I mean, it's a big part of the marketing for bikes, like you said, and
sure,
they use the 7,000 series or the 6,000 series. It's good to hear that we're not alone in not being able to tell a big difference in that. So let's talk a little more in depth about steel. So what's like a common steel material or tubing type that you would use, and what are sort of the pros and cons of it?
So the most common, and I would argue, unless it's a stainless, the most common steel it's all over. It's 4130, and that's kind of the alloy designation. And there are different variations of that, and they're very slight. And that goes back to what I was saying, where you may not notice. I doubt you would notice, but for the most part, it's all 4130 chromoly tubing, just different variations of that, just so that manufacturers can put their labels on it. But it's excellent tube alloy. It's been around for a long time. Most of us who've been riding BMX bikes as a kid and stuff, we can remember how chromoly was such a marketed term, because it was a level of alloy that was superior to just steel. So and that's what's primarily used in all of the frame tubes that we use or that we see today, and all the popular manufacturers, at least, and certainly everything that we use here at UBI.
Cool. And talk about too, like the sort of the failure mode of steel. Is that better or worse than other materials, or how is it different?
It's absolutely better than most. It's better than aluminum for sure, and it's better than carbon. I think it's rivaling, titanium. Kind of, they both have the same failure mode, so to speak. But so what it does is, if it's built correctly and the frame is used correctly, it's going to fatigue fail, which means you're going to get cracks. And most cases, most people will tell, they'll be able to see a crack, either, cracking in the paint or bubbling in the paint, or that you can feel it too. Something just doesn't feel right. It's not going well. So you take a look down at your head tube, down tube, or your BB or something. And you're like, oh yeah, there's a crack there. And that's a good time to get off that frame.
Well, can it be repaired? I mean, is it easier to be repaired than other materials?
Steel can absolutely be repaired. When you get into certain scenarios, though, it's up to the frame builder and how much they're going to cost and how much you want to save that frame. Because there's a lot of cases where places that I've worked, we look at a frame and it's like, yeah, we can fix this, but we can also just build you a new one for the price, So take a look at that. But some people are so attached to a particular frame that they're willing to go through that, and that's awesome. That's fine. There's certainly nothing wrong with that. But yeah, steel can be repaired a lot easier than aluminum. Yeah. We can get into the other materials too if you like, but steel can certainly be repaired.
Cool. Well, yeah, you mentioned stainless steel as a material, and that's one, we hear obviously a lot more about chromoly. So tell us a little bit about stainless steel and why you might use that in a bike frame.
Well, stainless steels generally, at least the tubes that are used in frame building, they're generally a little bit stronger. They have obviously better corrosion resistance. The downside to them is that because they're stronger, there's no such thing as a free lunch, right? So as something generally, particularly structural metals, as they get stronger, they also get more brittle. So you don't see a whole lot of stainless being built these days. Some people give it a shot and then they find out that, it's not the best material. We do want our frames to flex and move around and have that ability. So if a frame can't do that without cracking, then it's generally not a good idea to continue to build with that. So,
yeah.
And I have to preface this with, I don't have a whole lot of stainless steel experience. I've welded the tubes, but I haven't built a whole frame myself. But the reason why I don't have a drive to is because I've heard of what other frame builders are going through. So it's just not something that I'm, eager to dive into.
Yeah. Yeah. I mean, with all of these, obviously there are trade-offs, while stainless steel is going to be like more corrosion resistant or maybe a little bit stronger, that comes with the trade-off of it being harder to work with and maybe, the failure mode isn't as desirable. So yeah, that's definitely good to keep in mind.
Yeah. I think if I was a customer looking for a custom frame from a builder, I think if that was the case and they were interested in stainless, I'd try and talk them into Ti because it's about the same. They weld very similar. They're both very sticky materials, and you have to back purge both of them, or at least you should with stainless. And I think the end result with a Ti frame, Ti loves to be a bike frame, a hardtail, a road frame, cyclocross. Ti loves that stuff, and to take that away from Tis and then in order to have stainless is kind of silly to me, but that's just my opinion.
Yeah, well, let's talk about titanium. What are some more of the advantages to using titanium, and what makes it different from steel and aluminum?
Yeah, so I'm definitely, you'll hear it. I'm definitely biased to Ti because honestly, the one true sole disadvantage with Ti is the price, the cost of it, and that's arguably that's going to come down here pretty soon too. Because I just read something about some colleges are finding cheaper ways to turn it into the tubing that we use.
That's good news. Well, how much does it cost? I'm curious. How much does it cost like per linear foot compared to say steel or aluminum?
Yeah. So let's say a really expensive Ti down tube can cost like an inch and 7/8 or an inch and 5/8 down tube can cost around $100 for just the down tube.
Oh, wow.
Yeah. And on steel, you can get a down tube for maybe 35 to 50 at the most, I think. So,
okay. So yeah, at least twice as much for the
exactly
titanium. Okay.
And that's just the tubing, the machining. So if you have anything that's machined like a head tube or dropouts or bottom bracket, that's also going to go up because it's more expensive to machine titanium correctly than anything else. So anything else that we use in the bike industry.
Is there more labor involved in the machining, or do you need specialized equipment that's more expensive? What is the reason for that?
Yeah. It's a harder material to machine. It's a very elastic but hard material. It's got a really odd characteristic that way. So it'll go through your cutting tools really quickly. And you also have to pay really good attention to its setup because it's so flexible that it likes to kind of move around while you're cutting it. And that's generally not good for an efficient cut. So, and you got to keep it under, temperature because if it gets too hot, then it starts to oxidize really quickly, and that can be a detriment to its properties. So it's a tricky material to play with, but once you get a frame out of it, that frame will last your lifetime. So we'll get sick of looking at it and putting parts on it before that thing's ready to go.
Yeah, that's interesting.
Yeah.
So when we talk about titanium too, are we talking pure titanium, like elemental titanium, or is it also an alloy like steel or aluminum when you're working with it?
Yeah, it's absolutely an alloy too. There is commercially pure titanium used in certain aspects. You'll see it sometimes with brazons or, housing stops or saddles. Sometimes people will use it for a BB or even a dropout because it's cheaper. But the alloys that we predominantly see, especially in tubes, is it's called 325. And what that represents is it's 3% aluminum and 2.5% vanadium. And those are the two primary alloying elements. And then there's also a stronger tube or stronger alloy that's called 6-4. And it's the same thing. It's 6% aluminum and 4% vanadium. The downside with the 6-4 is it's obviously more expensive. It's less efficient or cost effective to manipulate, and it's a little more brittle. So we don't see it a whole lot, but there are some frame builders that use it to produce like a really ultra light frame that in relation to 325. But 325 is the bread and butter for the tie industry for sure.
Okay. So we've talked a little bit about aluminum, some of the advantages and disadvantages of using that for a mountain bike frame. What else do we need to know about aluminum?
Yeah, so aluminum's it's a funny one to me. I always kind of joke with students that especially the Cannondale, they're kind of were. I know they're not the first, but they were the first big company to start producing a lot of aluminum. And I kind of feel like the engineer at the time was probably, working hard at his desk, and his boss came down and said, "Hey, I need you to build, frames that are using aluminum." And he flipped through his engineering materials book and saw the properties and thought, "Man, I'm going to get fired," because, it's just the sole benefit of aluminum is that it's lightweight. It's like a third the weight of steel. Uh-huh. But otherwise, its fatigue life is horrible. Its strength is horrible. Its ultimate strength is just above its tensile strength, which is usually not a good match either, because that means that it's going to rip apart right after it starts to move. Uh-huh. So there's just so many things that makes aluminum just a very poor idea. But because it's so lightweight, we can use so much of it and still. And the cool thing about engineering, I guess, is that you can take a material like aluminum that, if you just look at the numbers, it's not a superior material at all for structures, but we can engineer certain things into it. So an example of this is, it's not very stiff. It's a noodle, but when you turn it into a large diameter tube, the larger the diameter, the stiffer the tube is, and it gets stiff in a hurry. So we can induce stiffness into the material, even though inherently its properties are very not stiff. And then we can, because it's so lightweight, we can add thicker wall to increase its strength as a tube, even though its inherent strength is not very good. So it's cheap and it's light. And those two things allow us to really manipulate and engineer, use the engineering properties that we can to make it a really awesome frame material for bicycles.
Yeah, that's really interesting the way you put that, its sole advantage in a lot of ways is it's lightweight, and that bike builders have compensated for a lot of the other drawbacks with the material to make it work.
Yeah, it's kind of cool. It's awesome in that way that, you just look at it in the book and you're like, no way is this going to work as a structure. But then we can manipulate it in ways that kind of enhance the properties that we want. Pretty cool.
Yeah. Well, so far we've talked about aluminum, steel, titanium. These are all metals and alloys of metals. But then the other big one is carbon fiber, obviously, and it behaves a lot differently than these other materials, right? What are the pros and cons of carbon fiber for bike frames?
Oh, man, there's a lot of pros. The biggest one that I can think of is the fact that we can manipulate its strength axes almost indefinitely. I mean, we can put them anywhere we want. And it's, if you take one way that I like to describe this is if you give me a piece of wood, we can all kind of have seen there's grains in wood, right? Mm-hmm. And those grains represent, a strong axis versus a weak axis. And when you're looking at metals, there are granular structures to metals that are kind of similar to how you would look at that piece of wood. But with carbon, that's up to us. We have the opportunity to put that grain of wood this direction or that direction, mm-hmm. or both. We can stack them on top of each other in what's called a layup. So what that does is it gives the designer an opportunity to create an axis that's stiff, and then maybe a 45 degree or a 90 degree axis that is compliant. And it can create a torsional stiffness, but a bending compliance, or vice versa. It's just incredible what we're able to do when we have the say on where the strength axes are going or coming from. So that's the big reason why we're seeing everything pop up in carbon, because we have the ability and we're learning more how to manipulate it and how to fabricate it effectively. We're seeing it in, there's wheels right now from Santa Cruz that are, they have a lifetime warranty. And
yeah,
anybody that's seen, a downhill race, the wheels after a downhill practice, they look like, they're a pit bull chew toy. And to think that a carbon frame or a carbon wheel can get through that is, ridiculous. But not only can they do it, but they're to the point now where at least Santa Cruz feels comfortable in offering a lifetime warranty. So we're making huge strides with it. I know the resin is still has a lot of growth there in the strength and the bonding properties with carbon. And yeah, it's a fun material. It's definitely one that we're going to see continue to grow. The downside to it is, and it's kind of a bad one for sure, and that is that it's expensive and it's not great on the environment to produce. But then also, we have yet to find, and I know that there's other universities as well that are looking into this. We've yet to find a way to recycle it, like truly recycle it, because the way we're doing that now is we basically throw all this carbon to a pit, we chew it up, and then we put it into a mix where we're applying mold. It goes into a mold, and those molds are used for non-structural components. So we're seeing them in maybe the casing on your computer is this kind of carbon, or your phone might have a case that's this kind of carbon. But it's not a structure, and it's not structurally sound, and it's certainly not something that you're going to turn around and make into a bike again. So,
right. That's interesting. This is good news, I guess, that at least we're finding ways to reuse it. I mean, last I heard, there were warehouses full of carbon bike frames that people didn't know what to do with them. They were hoping to recycle them, but yeah, it sounds like they're still trying to figure out the best way to do that.
Yeah, as far as I know, there are still warehouses full of it. It's sad. It's sad for sure, and it certainly weighs on my mind because I ride carbon frames all the time. But I'm hoping that we find something that we can do cool with the leftovers, because there's a lot of leftovers. It's not just the bike industry; it's the aircraft industry, the aeronautics industry, military. We all use this stuff, so it's piling up.
Well, is it repairable? I mean, I guess it depends on the situation, but is that something that UBI talks about or looks at in terms of how carbon is repairable?
We don't. UBI doesn't specifically, unless somebody asks, just because we don't deal with it. It's not in our curriculum as far as the frame building side goes, but it is absolutely repairable. I think one of the downsides to it is, if you buy a carbon frame, the bike industry is moving so fast, and that, if let's say you crack your top tube and the bike is 5 years old, you're looking at, okay, if I fix this, I can spend that money and do that. But the bike doesn't have boost, it may not have a tapered steer tube, or, some kind of component that's changed to the point where it's like, man, I would really like to have the benefit of that. So why spend the money on fixing this frame?
Right.
It's we're moving so fast in the bike industry as far as the progression and the design of things that, our carbon frames are almost like computers these days, where 2 or 3 years they're going to be a little bit behind of what's available, what's out there, compatibility wise.
Yeah. So thinking about this as, an engineer and thinking about the structure of carbon, is it possible to repair it more easily? I mean, basically it's like a matrix of these fibers, and if you're able to patch over it, does that bring its strength back up to where it should be compared to metal bike frame?
Yes. Yeah. It's not where, if you have it repaired correctly, it's going to be, kind of like your own bone when it breaks and it heals correctly, the area where it broke is going to be stronger than it was before. So carbon is, as far as I understand, the people that do it, the Calfees and the Ruckus, when they repair it, that area is going to be stronger than it had been previously.
Yeah, that's interesting.
It might weigh a little bit more as well, but that's the downside maybe to repairing. But will somebody know? I doubt it. I doubt you could tell the difference.
Yeah. So let's talk about some less traditional frame building materials. What do you think about things like wood or bamboo? I mean, are there advantages to using those kinds of materials, or is that just kind of like a fad or like a artsy kind of project? Boy,
so this is purely my opinion, just looking from the outside. I've ridden a bamboo bike and I've seen a lot of wooden ones, a handful of wooden ones, but I've never worked with them myself. So take this all with a grain of salt. But I think wood is a great material just for any kind of structure. So the people that apply it to a bike and they do it well, it's beautiful. And it's got an interesting ride characteristic, at least the one that I rode. But as far as how it performs relative to, tie or even steel and carbon, no, it's not. You're not going to have the same performance advantages. It's not as lightweight. It's not going to have the stiffness that it does. And if it's done correctly, it'll last a while for sure. That's wood. Bamboo specifically is an awesome way to go because of its resource ability. It's like a weed in a lot of parts of the world. So if we can, continue to learn how to choose tubes and grow the tubes that work well for bicycle frames, I think Calfee has done a really good job of showing its niche in the world, not just, around in the US where, we see a lot of them as kind of a niche fad kind of a bicycle. I think it has a really good opportunity to continue to grow in less fortunate parts of the world. And that part of it I'm stoked about.
Yeah. That just blew my mind that you said growing tubes and like shaping them. And
yeah,
that's a cool way to think about it though. I mean, yeah, it's not like you're just cutting down a random piece of bamboo and slapping it onto a bike frame. I mean, there's still engineering that goes into it and a lot of thought that goes into how that comes together and everything.
Absolutely. Yeah. I think that's probably something that I can't speak for him directly by any means, but I'm sure Calfee had a couple sleepless nights thinking about how am I going to, choose, particular tubes, because you can't just cut down any bamboo shoot in your neighborhood and call it a frame.
Yeah.
There's definitely some education that needs to go into that.
Yeah. All right. Well, we're going to take a quick break, but when we come back, we're going to talk about the UBI frame building class and how that's structured and what people get out of it. So stay tuned. You can't see me, but I'm wearing an awesome Singletracks hat right now. It's actually the reason my voice sounds so amazing. Okay, so maybe not, but you never know until you get a hat for yourself. Go to shop.singletracks.com to find Singletracks hats, t-shirts, stickers, tubular headwear, and can coolers. Shipping is free within the USA, and your purchase helps support the Singletracks podcast. That's shop.singletracks.com, and thank you for your support. So, Rich, talk to us a little bit about the UBI frame building class. How's that set up, and who is that structured for?
So we have the three main classes that we have are brazing steel. And in that brazing steel class, you get to choose if you do a fillet braze frame or a lug frame. And then we have a TIG steel, which is TIG welding. And then we have a titanium TIG class. And all of our frame classes are 2 weeks long. So 10 days. We don't do anything in the weekend. And in those 10 days, you learn to fabricate. You learn to draw your full-scale model of your frame that you're going to build. And we talk about, frame design and frame fit. And then the rest of the time is fabricating an awesome frame. Yeah, so it's an experience that anybody can walk into. We've had people take the class that didn't even know what a bottom bracket was. And then we've had people that, they've built 5 or 10 frames on their own, and now they're ready to come in and ask some questions to fill in the remaining gaps that they have. And age-wise, we've had them all. We've had, kids that are just eligible to sign up, and we've had people that, they're 70 years old and they've always wanted to do it. It's been a bucket list, and the whole gamut. It's awesome.
Yeah. Well, I mean, what do most people hope to get out of this? I mean, I guess it probably runs the gamut as well. You've got people who do it just for fun and they're like, hey, it might be cool to build my own frame. to people who are like, I'm going to be a frame builder and like make bikes and sell them. So what's sort of the mix with the students?
The most popular is the student who wants to see what it's like, with the idea that, maybe there's a chance that they could start something on their own, kind of grow it from a hobby.
Yeah.
That's probably the most popular kind of student that we have. But then we have the ones that, they're all about it. They've got a machining background or an engineering background, or, their parents were into some kind of fabrication or art or something like that. And, they knew early on, or they went to a NABS show and they were like, man, this is what I got to do. And so we get, a handful of those. And then we get on the other side of the spectrum, we get people that are like, look, I just want to build my one frame that I can say I built myself and, ride it around, with my grandkids or with my kids or just show people that, I built my own frame.
So the class itself, 2 weeks doesn't sound like a whole lot of time. What exactly do people do? They basically spend most of the time building, or how much of that is like instruction where you're, sitting in a lecture? And
it's pretty minimal lecture. We pride ourselves on keeping it minimal just because as you mentioned, there's not a whole lot of time to learn all those things, to learn how to fabricate, how to draw the frame, and then physically build the frame. So it's a tight curriculum. It's I remember the first days that I was working here, the first few classes that I sat in at, I was like, this is madness. Like these students are getting so much information thrown at them. But the good thing is that the reason why it works is every student that I've seen has some level of enthusiasm. They're stoked to be here. So that goes a long ways. And then the curriculum that UBI has established since, the late 80s, it shows. There's, our priorities are certainly keeping everybody safe, but then after that, it's teaching people how to build frames in a very efficient way. So it gets done for sure. It's sometimes it's surprising, but at the end of the 2 weeks, people leave with a frame.
Yeah, that's cool. I imagine frame building too is like a lot of things where you just learn so much by experience too. Your first frame isn't nearly as tight as like your 100th, right? So I guess that's part of it as well.
Absolutely. And I'm glad you said that, because there's some people out there that feel like either, I don't know where it started, where, if a student said that they're a master frame builder after one class, it's certainly not the case. You're not going to have anybody come in and learn any craft. I don't care if it's, plumbing or playing a guitar or whatever. Nobody's going to be an expert at anything doing it for 2 weeks. So anybody that hears that UBI will turn you into a master frame builder in 2 weeks, or even if you take all of our classes, you're still not going to be a master frame builder. It's kind of silly. But what you are going to be is somebody who learned how to, use a file and how to design a frame and how to miter tubes and how to weld thin-walled tubing and or braze, lugs or fillet. It's an experience, but it is up to the individual person to go home and practice and practice and practice and practice and practice and learn a lot of lessons that we can't teach you in 2 weeks.
Yeah. Well, I imagine a lot of frame builders come at this as like a self-taught type of skill, or maybe they apprentice under someone. So what are the advantages of taking a class like this versus just trying to like figure it out on your own or learn from somebody else?
The biggest advantage is that you've got a curriculum that's been established for a long time. And some people look at this as a negative. They're like, okay, I can go to, Frame Builder and watch him build my frame or participate with him in building this frame. Or I can go to UBI where I got to share with, 7 other students and an instructor. I can tell you that I've built somewhere around, I'm guessing around 150 frames, and almost every single one of those frames, I can tell you that there's something either I wish I could do differently, or there was an obstacle that I had to work around. Mm-hmm. And the fact that you get to come to UBI and you get the experience in education that we have, but then also you get to build 9 frames with 8 other people. So you get to talk about and work through different obstacles that you're going to have. So you get a jump on basically 9 frames, whereas somebody who's just doing it, with one instructor, one shop, in the middle of nowhere somewhere, you get one shot at a frame, and then you're going to go on to your next one and have to learn something again where, if you were to talk to and converse with and learn with the other students, you're getting out a lot of experience in one shot. So that to me is the biggest advantage at being at UBI versus, somewhere else or learning on your own.
Yeah. Yeah. There's a lot to be said from learning from other people's mistakes and also, not picking up bad habits too, which I imagine you would if you talk to the guy who builds frames, and he can probably give you some useful stuff, but there's probably also stuff that he's doing that's not exactly right.
Absolutely. Yeah. And also not everyone obviously, but a lot of students I'm still in contact with. I've had students email me with, they're looking at a welder on Craigslist and they're like, hey man, can you take a look at this and see, give me your thoughts on it, or even setting up a brand new welder, or, they get to their fourth frame and they're doing, curved seat tubes. So they ask my opinion on how to fixture it up or something. And I'm happy to do that. I love doing it. It's one of the perks of my job. So a student who leaves here, we don't forget you, and by any means. It's we want to keep in contact, and if you're building frames and doing awesome stuff, we'll even market the heck out of it for you. So that's another advantage to being here.
Yeah, that's cool. Well, thanks, Rich, so much for joining us and for filling us in on mountain bike frame materials and construction techniques. We really appreciate it.
Yeah, my pleasure. Thanks for having me, man.
Yeah, so if you're interested in perhaps building your own bike frame, check out the United Bicycle Institute online, look at their class schedule, and find out more about frame building. And also, if you're enjoying the Single Tracks podcast, we'd love to have you rate us on iTunes or wherever you get your podcasts. That's all we've got this week. We'll talk to you again next week. Peace.